In this module, we will cover the memento pattern, sometimes called the token pattern. It's all about capturing and externalizing an object's internal state. I'm Kevin and I'll guide you through it. We'll start by describing the pattern using a real-life example. As a real-life example, for once we will build upon something from a previous module. We will use the memento pattern to store a command's internal state to support undo actions. We will map that to the structural design pattern and will implement this real-life example in a demo. After that, we'll continue with learning about use cases, pattern consequences, and related patterns. Let's continue with describing the memento pattern. The memento pattern is a behavioral pattern from the Gang of 4 library of design patterns. The intent of the memento is to capture and externalize an object's internal state so the object can be restored to that state later without violating encapsulation. In other words, this pattern will allow us to store and restore private field and property values. Let's clarify that with a real-life example. We're going to use undo functionality of commands. If you've watched the previous module, you know what this is about, and normally I try to keep the modules as separate as possible. But as it's such a nice use case to explain the advantages and disadvantages of using a memento, I'm going to build upon what we ended up with in the previous module. To be honest, I don't see this pattern used that much these days. With that in mind, if you don't want to learn about commands, simply look at a command as a class that has some internal state, so private state, that needs to be stored to be able to undo the command. It's easy enough to store public state, but private state is different. An example we previously used was a command that added an employee to a manager's list of employees. That command needed to know about the employee to add, about the manager, and it also needed a repository through which interaction with the underlying data store could happen. The manager ID and the employee, that's internal state. We used the command manager that was responsible for executing the command and storing necessary information about the command to undo it. We did that by storing the command object itself in memory. And while that works, this could mean we'd be storing too much information. We don't necessarily need to store the full command object. We simply need to store its state, or part of its state. Let's switch back to that command implementation. If that's what we want, we could make the state public and access it as such, to store it somewhere. Yet, this breaks the command's encapsulation. And that is what the memento solves. It allows saving and restoring internal state without breaking encapsulation. Let's look at our command again. The internal state we want to store consists of the employee and the manager ID. We don't need to store a reference to the repository or anything. That remains the same for all add employee to manager list commands. The first thing that we'll need is a memento class that can contain this state. A good name would be add employee to manager list memento, containing the state we want to store via properties. On the command itself, add employee to manager list, we would then add two methods, one to create a memento and return it, and one to restore a memento. That's a method that accepts the memento and is responsible for restoring the command's state. And now we need something that manages this. That's our command manager. In an implementation we ended up with in the previous module, we stored commands on a stack. We no longer have to do that. This time, we can store the mementos on a stack. Undoing a command then means that we take one existing add employee to manager list command, restore the memento on it, and call the undo action. And that takes care of our use case. Important here is that we want to provide two different interfaces to this memento. One wider interface that is used by the command to create a memento. This passes through state and has access to set the state. The other interface to the memento is used by the command manager. That one stores these mementos and passes them through to the command. But it cannot change the memento itself anymore after it has been created. It has access to the getters but not to the setters. So that's a narrow interface. We can achieve that with private setters, as we will see in the implementation. Let's map this to the pattern structure. We've got 3 players in this pattern. The first one is the memento itself, which maps to our addEmployeeToManagerList memento class. It is responsible for storing the internal state of the originator object. It may store as much or as little of the originator state as is necessary. Important here is that we try to protect this state against access by other objects as much as possible. That's that wide versus narrow interface explanation we just covered in the previous clip. Then we have the originator. That maps to our addEmployeeToManagerList command. It's responsible for creating a memento with a snapshot of its current internal state. It also uses the memento to restore its internal state, for example, via a restore memento method. Lastly, we have the caretaker. This object is responsible for the memento's safekeeping. It shouldn't operate on or examine the memento's content. It simply passes it through to the originator. That is what the command manager does. Such a caretaker can work on 1 or more mementos. In our use case, the command manager is a caretaker that works on multiple mementos. Let's check that out with a demo. We'll start this demo with copying over the implementation and program classes from the previous module. For once, we will work on what we ended with there. There we go. Now let's add a memento class to hold the internal state of our addEmployeeToManagerList command. We name it addEmployeeToManagerList memento. Seeing we want to hold the manager ID and employee, we give it 2 properties, a manager ID and an employee. We also give these properties private setters. Like that, the caretaker will not be able to modify the memento. Seeing our properties have private setters, that means we can only set them via the constructor. So we do have to add a constructor which accepts the manager ID and the employee. But that makes sense because a memento without these fields doesn't make sense. So it's a good idea to convey that meaning via the constructor. And then we need to extend our command a little bit. The first thing we need is a method that will create a memento. So we name that createMemento, in which we create an instance of our addEmployeeToManagerList memento. And then we need a method to restore the state of the command. We name that restoreMemento. This is used to restore our command's state and it accepts the memento. This does mean that we can no longer keep the manager ID and employee fields at the level of our command read-only, as we now have to be able to change them outside of the constructor. There we go. That takes care of that. And that's it for our command class, in other words, the originator. What is left is the caretaker. That is our command manager. As you notice, once you start combining different patterns, which is often the case, the same class will often be used by the different patterns, thus mapping to different component names from the pattern structure. The first thing we need to do here is change the stack. We no longer want to store commands on it, we want to store mementos on it. So it's not a stack of iCommand anymore. It's a stack of addEmployeeToManagerList memento. Let's also change the name and new it up. We also want to add 1 command field. We need that to hold our addEmployeeToManagerList command. This command will be reused. Also, we don't instantiate it yet. We didn't store a reference to the repository in our memento, as that remains the same over all command instances, in case you need more. Therefore, we need to set this field to the first instance of the command that's created by the client. so we can get a hold of the correct repository reference. That's what we do in the invoke method. Also, note that we do have to cast the incoming I command to an add employee to manager list command to be able to store it. We are now again tying this to a concrete implementation. In a real-life scenario, this might become a bit more difficult to manage, but we'll get to this and other disadvantages right after we finish our implementation. So let's first continue with that. So, next to storing our command, we also push a memento on the stack by calling mementos.push. Now, as you notice, calling create memento on command doesn't resolve. That's because create memento is implemented on the concrete command class, while command is of type iCommand, the underlying contract or interface. That means that we need to cast here as well. And there we go, now the code does resolve. But as you've noticed, we are now tying the invoke method to one specific type. That's a bit of a disadvantage. And there's more, but we'll look into that right after we finish writing the demo. That's it for invoking the command. When we want to undo the last one, we first check whether mementos exist in the list. And if one does, we restore that memento on the command by calling into restore memento, passing through the memento we pop from the stack. Now, the state of the command is that of the memento. And when we call undo, we effectively undo the correct state change. For undoing all commands, we do the same, but in a loop that loops through all mementos. Let's try this out. We do not need to change anything to the client code. As far as that is concerned, all of this is of no importance. So this code, which we copied from the command demo, remains the same. Let's give that a try. And there we go. This still works as expected. This is the exact same outcome we had at the end of the command demo. So we're now using mementos. But you can already see a negative consequence here. The command that's reused is always the same command. If you want this to work with different commands, which you typically want the command manager to do, you will have to implement support for that. Moreover, you'll also need memento classes for each command. And it would also be nice to find a solution for all this casting. So this has a tendency to become a hassle pretty fast. We will look into the consequences of this pattern right after the use cases.